Good morning, students. As in the previous class, in the previous lecture, we had discussed about magnitude of the physical quantities. What are the carefulness we had to adopt while doing the writing the magnitude of the physical quantities. These things we had discussed, and I had given a question regarding that magnitude of the physical quantity. Regarding the magnitude of the physical quantity, there was the question. The question was, the radius of a proton is 10 to the power minus 9 micron, and radius of the universe is 10 to the power 28 centimeter. Name the physical object whose size is approximately halfway between these two on logarithmic scale. Means we have to find out the physical quantities whose size is in between the radius of the proton and the radius of the universe, that is in between 10 to the power minus 9 micron to 10 to the power 28 centimeter. So look at here. The radius of proton is equal to 10 to the power minus 9 microns, and it can be written as 10 to the power minus 9 into 10 to the power minus 6 meter, that is equal to 10 to the power minus 15 meter. Radius of universe, it is given as 10 to the power 28 centimeter, and it is expressed in meter as 10 to the power 26 meter. Now in the question it is given that halfway between these two on logarithmic scale, halfway, suppose this is A and this is B. Suppose this radius is A and this radius is B. Then log y is equal to log base 10 A plus log base 10 B upon 2, and it can be written as log 10 to the power minus 15 plus log 10 to the power 26 divided by 2, and we can write it as log y is equal to power bases are same, base and the exponents, it is log base 10, it is log base 10, both have log base 10, so it becomes, what will be the value? It will become minus 15 log base 10 plus 26 log base 10 divided by 22, and it is equal to minus 15 plus 26 divided by 2, and this will be equal to 5.5. Then y is equal to log y is equal to 5. Log y is equal to 5.5, and from here we can write it as in exponential form. It can be written 5.5, and this can be written as 10 to the power 5 plus 10 to the power 0.5, and this can be written as y is equal to this is multiplication, this will be the multiplication, so y is equal to 10 power 1 by 2 into 10 to the power 5, and it can be written as y is equal to under root 10 into 10 to the power 5, and its value is approximately equal to 10 to the power 6. Means the given quantity has the order of magnitude of 10 to the power 6. This is the order of magnitude, and the quantity which is lying between the radius of the proton and the radius of the universe is of the order 10 to the power 6. And radius of the moon is the radius of moon is 1.738 into 10 to the power 6 meter, which is approximately equal to 10 to the power 6 meter. So moon is the required physical object. Moon is the required physical object. So on halfway between the logarithmic scale, after doing calculation, we had calculated that the moon is the physical object whose order of the magnitude is of 10 to the power 6 meter. Now we will discuss about fundamental and derived units. Fundamental and derived units. Fundamental and derived units. Now, what are fundamental units and what are derived units? As you know that, okay, while studying physics, we have to come across a very large range of physical quantities. And since we are in the need of very large range of physical quantities, then obviously to specify the unit of that physical quantities, we need large units. So it is not possible to give a particular unit to each and every physical quantity. So we choose certain fundamental units for some fundamental quantity. And on the basis of that fundamental units, we find out the derived units. Suppose in mechanics, the arbitrary units of any three physical quantities that is mass, length, and any three physical quantities, mass, length, and time, the units are kg, meter, and second. Means while dealing in mechanics, we are arbitrarily choosing three physical quantities, and the other physical quantities which can be used in mechanics can be expressed in the terms of only these can be expressed in terms of only these physical quantities. So, so these units are called as fundamental units or base units in mechanics. These are called fundamental units or base units or absolute units. Absolute units in mechanics. The fundamental units for length, fundamental units. Length, suppose length is the physical quantity, then its fundamental unit is meter. Mass, then kilogram. Time, then second. These are the fundamental units. Now derived units. We are discussing derived units. The other physical quantities which can be expressed in terms of fundamental units, and these are called as derived units because they are derived from the fundamental units. For example, suppose we are writing second inverse or meter square or kg per meter. Look at here. Here it is not only second, it is 1 upon second, take a 1 upon time. So it is derived from the fundamental unit of time. Here meter into meter square, it is also derived from the fundamental unit of length. Kg meter, two fundamental units are involved to make a physical quantity. So these are called as derived units. Now, apart from these are the fundamental quantities we had discussed in case of mechanics. But in other areas also, there are various fundamental quantities which can be used in other areas also, like in thermodynamics for temperature, in current electricity, for current, for luminous intensity, amount of substance. These are the four additional fundamental quantities. There are there are four additional additional fundamental additional fundamental quantities. Four additional fundamental quantities which are used in other areas of physics, which are used in other areas of physics. So what are the fundamental quantities and what are the areas? That is temperature, which is generally used in thermodynamics. Temperature. For temperature, the fundamental unit is Kelvin. This is the fundamental physical quantity and its fundamental unit, Kelvin. Current, ampere. Luminous intensity, that is candela. Ampere A candela, it is CD. Candela, it is CD. And the one is amount of substance which is used to measure the quantity of matter. So first one is temperature, second one is current, third one is luminous intensity, and fourth one is amount of substance, and this amount of substance is called as mole. Amount of substance is called as mole. Apart from these fundamental and physical quantities, and apart from these fundamental quantities, fundamental units, derived quantities, derived physical quantities, derived units, there are certain units which are called as practical units, which are either fundamental or derived units. So now we will discuss the practical units. Practical units. Apart from fundamental or derived units. Why they are called practical units? They are called practical units because these units can be either expressed in terms of fundamental units or in terms of derived units, or they are interconvertible. Means they can be written in various units also. There is no any specifications like that. We suppose there is length, so we use only meter. If there is mass, then we use only kilogram. There is no such type of restriction for practical units. So for practical units, let us discuss example, that is light year. Light year is a practical unit, that is practical fundamental, that is practical fundamental, that is practical fundamental unit. And the light year can be expressed in various forms like kilometer, meter, centimeter. In what way we want to express light year, we can express. Horsepower, horsepower is the practical unit for power. These practical units, these practical units can be expressed in other units also. Example of that: 1 mile, that is 1 mile can be written as 1.6 kilometer. 1.6 into 10 to the power 3 meter, or 1.6 into 10 to the power 5 centimeter. So it is a practical, 1 mile is a practical unit. Now some certain characteristics. What are the characteristics of base or a standard unit? Characteristics of base or standard units means what are the quality preserved by, what are the peculiar qualities preserved by a unit so that it is recalled as a base unit, a standard unit, absolute unit, or fundamental unit. So we will discuss. I am writing, just explaining, I am writing the points and explaining after that. Well defined. Well defined means the first and foremost thing is that base unit or standard unit or fundamental unit is well defined. There is no any ambiguity in the definition of that unit. It is easily recognizable, or there is no any question of query regarding the expression of that standard unit or base unit. Second point is invariability. Invariability. Invariability means to say that that base unit or standard unit is invariable. It does not varies from place to place or person to person or positions to positions or by other physical parameters. If other physical parameters, that unit is not going to be changed. Third is its accessibility. Accessibility. Accessibility means to say that it is easily accessible, means whoever, wherever wants to find that unit, they can easily find that units. They are convenience to use. Convenience in use means if there is very typical or cumbersome task to use or install any fundamental unit, then it is not possible for each and everyone to measure or use the fundamental quantities in a mass. So the physical quantities are so designed that they can be easily understandable to each and every person, each and every common person, and that person is easy to use the base or standard quantity. It is not possible that any unit has all these characteristics at a time possible, all the characteristics are available to any standard unit at the same time. So there must be compromise compromise with any of the characteristics. Compromise with any of the characteristics. Now, while writing the unit, following conventions are taken into mind. Following conventions are kept in mind while writing a unit. And what are the first convention is, suppose you are writing the name of the scientist, because there are various units which are named after the scientist, and if you are not writing the name of the scientist, then it can be written as Newton, not like Newton. The unit is expressed in the first letter is a small letter. Second thing, if you are symbolizing by a single letter, then you can write and, not a small. It is the wrong way to write, it is the right way for writing. Similarly for meter, so for meter you write m. For meter you write what? A small m, not capital M. Means if you are writing the short abbreviation for the scientist, then it can be written as capital M. If the scientist name is given, this is suppose Farad, then capital F, not a small f. But if you are using the meter, then you can use a small m. Symbols cannot be written in plurals. Plurals are not acceptable for symbols. You can't write 5 meters. You can write it, this is the wrong way. You can write it as only 5 meters. You can write only 5 meters. You can't write 7 arcs. You have to write, this is the correct way. You have to write 7 arc. This is the correct way. Fourth one is, not more than one solidus is used. Not more than one solidus is used. What is the meaning of solidus? Solidus means per. The slash we use, no? So that is called solidus. So suppose I am writing the thing 1 pias, 1 POIS, 1 pias. 1 pias can be written as 1 gram centimeter inverse. This is the correct way. Not 1 gram per second per centimeter. this is the wrong way to write. You can write it as, if you want to write it, you can write it as 1 gram second inverse centimeter. This is the right way. But 1 gram per second per centimeter, this is the wrong way. Means more than one pass is not used while writing a single formula or single physical quantity, physical unit. If you are writing expressing a derived unit, if you are expressing derived unit, then not more than one pass is required. And the last one, suppose you are writing 1 liter. 1 liter is equal to 1000 centimeter cube. It can't be written as centimeter cube. This is the correct way. So this is all about the fundamental quantities, fundamental units. Just like AME, it is the correct way to write, and A dot M dot U, this is the wrong way. EMF, this is the correct way, but E dot M dot F, this is the wrong. So this is all about the fundamental units and derived units, and in the next class we will discuss about the standard units. What are the standard units of length, time, mass, फिर solid angle, plane angle, then Kelvin, mole, all the fundamental units we will discuss one by one in the next class. Thank you, students. That's all. Thank you.